Between the two towers of a suspension bridge, each of the two main cables has the shape of a parabola. The two towers are 2 kilometers apart, and we have closely and equally spaced vertical cables from the main cable to the horizontal roadway. We need to set up a definite integral which gives the length of each main cable between the two towers. Let's draw a figure. Here is the first tower, and the second tower is going to be identical, so I'll draw it over here. Now I'll draw a parabola between those two towers. Now I'll place the x-axis to correspond to the parabola. Since parabola is 1/10 times x squared, it passes through the origin. It touches the origin over here. Here is our x-axis. Our y-axis. I need to redraw it because it's not upright. There it is. This is the x-axis and this is the y-axis. Here we have x value of 1 kilometer, here we have x value of 0, and here we have x value of -1 kilometer. We need to calculate the length of each main cable. It is sufficient to calculate the length of one of those two main cables because both main cables are the same, so I only drew one of them. Let's take a look at a unit length of the main cable. As we go along the cable, this unit length is ds, and when we go along the cable by ds, we also go in the x direction by dx, and in the y direction we move by dy. We know that both dx and ds are greater than 0. We set it up this way, so that we move from the left to the right, from this leftmost point over here to this rightmost point over here. We move along the cable and we move along the x-axis. So our total length is going to be equal to the integral of those infinitesimal ds segments of the line. And in this case, we're going to integrate along the x-axis. Since we're going to integrate along the x-axis, we need to set up the integral so that it is along the x-axis. So we need to express ds in terms of dx. Using Pythagoras' theorem, we know that ds squared is equal to dx squared times dy squared. Let's take out dx squared, and what remains is 1 plus dy over dx squared. Now, using the fact that both dx and ds are greater than 0, and that this value over here within the parenthesis is also greater than 0, because this is a complete square and this is a positive number, we can take the square root and obtain a simple relation. ds is equal to square root of 1 plus dy over dx squared times dx. So now we know how to integrate over ds using the x-axis as the axis of the integration. So we integrate from x is equal to minus 1 kilometer to x is equal to 1 kilometer, and we integrate square root of 1 plus dy over dx squared dx. Since y is equal to 1 over 10 times x squared, dy over dx is equal to 2 times x over 10, that is x over 5. So our integral is square root of 1 plus x to the power of 2 over 25 dx, where x goes from minus 1 to 1. And this way we've set up the integral, and we don't need to solve it because the problem doesn't ask us to solve it.